Hello, my name is Ricardo Sales, and today I will be talking about how Simcenter testing solutions can help to enable productivity in your operational NVH testing campaigns. Let's start by looking to some common pains that are part of these campaigns. In the first phase, when the instrumentation is done, a lot of errors can happen, for example, with the sensor placement or directions. If those errors are not detected on time, that will affect a lot your testing, and maybe you need to rerun them, which will affect time and cost of the campaign. Another important point is the quality of your data. There's a lot of checks that can be done on the spot to make sure that what you measured is exactly what you need and the quality of your data is correct. When that is not done, when the instrumentation is still in place and the prototype is available, test needs to be redone, and of course, again, it will affect a lot the time and cost of the campaign. After the data acquisition, of course, the processing needs to start. And that's sometimes a very challenging part because a person doing the processing of the data sometimes is not the same one that measures the data. So in big campaigns where there's a lot of data involved, it's important to have annotation and documentation of data so this process can run smoothly and will not affect and delay the campaigns. And finally, after having processed and analyzed the data, engineers need to report it to other departments or to the management. If there's not a very well-defined reporting methodology in the company, of course, a lot of data will be lost, and there's a lot of people that will not be receiving the correct information that comes from these campaigns. So this is a very important phase as well, needs to be well thinked. So I think at this point you maybe recognize some or all of these problems in your daily work. So if yes, I wanted to show you today how we can use Simcenter testing solutions to get rid of these pains and make sure that your NVH campaigns are with full productivity all the time. For this demo case, we use our SimRod vehicle, which is an electric vehicle that we use for testing, and we place some sensors around it. The first one is the microphone close to the gearbox because we know this is an important sound source for this car. We also put a triaxial accelerometer in the drive shaft and also a single axis accelerometer close to the seat rail to make sure that we can correlate both vibrations. We also use the GPS so we can all the time see where we're driving during the test. And also to make sure that we have very well the orders extracted in this demo case, we instrumented tacos in the engine and also in the drive shaft. As a plus, we use a GoPro camera so we can also synchronize the video from the GoPro with all the data that we acquired. Let's see how it works in the software with Simcenter solutions. So this is the steps that I will be showing today. So we will go through all the steps from the measurement to the reporting of the data and using this demo case that I just mentioned. Let's start with NVH test setup and measurement. So operational NVH testing campaigns requires different sensors to be instrumented around the vehicle. One key aspect to optimize this campaign is being able to combine different tests in a single campaign, so a lot of data can be measured at the same time. To be able to do so, you need to use an acquisition system that supports not only NVH sensors, but all of different sensors, for example, also durability sensors. Also, another important thing is how this hardware, this acquisition system is being used. There's different ways to use it. For example, during the operational NVH campaigns. Imagine if you are in a proving ground with a driver executing the measurements, and the driver is not an experienced person with this software. So in standalone mode, most of the operations will happen automatically. So this is the perfect mode for this kind of measurement. Another very nice technology that was combined with front ends is the tablet-based applications. These applications helps with real-time feedback during the test and also allow on-the-spot validation of the data. The third and the last one is the front-end mode. This is a classic way to use a front-end with a PC, combined with a PC and a Testlab application running in the PC. Of course, with this node, you can use all of the advanced processing capabilities of Testlab during the measurements and also do extra annotation and documentation on the spot. So it's very important to have a flexible system to cover all the Operational NVH campaign needs. So during the instrumentation phase, a lot of mistakes can happen. One of the tools to support this and to make sure that this process is error-free is the Simcenter instrumentation app. This is an app application running on a tablet or on a mobile phone that is directly connected to the channel setup of Testlab. With that, the engineers can enter in real-time information from any sensor, for example, directions, name, and even take pictures of the sensor placement. So this is very important to avoid errors and to make sure that this phase is really well done. During the measurements, also, it's very important to annotate the data as much as possible. Simcenter Testlab offers the possibility to annotate the data with your keyboard. If you have PC connected during the test, you can use the keyboard to annotate and to inform any event that happens during the test. So the person processing the data will make sure that the person processing the data have all the information needed. And another way to document your data very well done is using user properties. With these user properties that can be defined in a company level, data can be entered before the test, and all information, for example, like who executed the test, where, and the vehicle conditions can be entered, and also will be available for the person processing the data. So that's also very important part of the measurement campaign. So with this first part of the demonstration, I wanted to show how the Simcenter solutions can help you to make sure that you measure the correct data and avoid any mistakes during this first phase of your Operational NVH testing campaign. In the second part, I'll show how the data acquired can be validated on the spot. So a lot of issues can happen with the data during the measurements. So it's very important to do data validations on the spot or just after it when the instrumentation is still in place and the prototype is available. There's a lot of nice tools that can be used for that. For example, audio replay and filtering and also quick spectral analysis can be used by the driver or by the engineer executing the test on the spot to make sure that everything is correct with the data before going back to the office and to process the data. So this is a very important part of your Operational NVH campaign, and I want to show in the next part how you can use Simcenter Testlab software to make sure that this data validation runs smoothly. So what you see now is Simcenter Testlab Neo. In this project, I have the data that I measured with the SimRod, as I explained before. It's about 25 minutes of data that we recorded in a free drive. So we start by checking how we want to see this data. So, for example, there we have something that we call the pivot tables. There, based on the information that you want to see from the data, you can choose which visualization you prefer. So let's take degrees of freedom versus function here. So you see that I have all my channels, and here in the columns I have the functions that I recorded. So if I select it directly from the pivot table, I start to see the data in the screen. So I have here my accelerometer and my rotational speed, my microphone. I can also see my GPS data and all the CAN bus and everything that I measured in the car. So let's see how this data can be visualized together. So I can select some of the data here, for example, to make sure that we see them all together in a single display. So here what you see is the Google Maps display with all the parts that we drive here were very well identified. Here we have the data that I selected, so the RPM and the microphone, for example, and the GoPro video. So when I do some audio replay, I can see all this data visualized at the same time. So for example, I can zoom in a certain part of the data, and then you see that everything is zoomed out together. So let's take part of the data, for example here. Yeah, and then I can do some audio replay. So you see here all is moving in a combination. So okay, so here you see how we can replay the data in synchronization. So we also can do some audio filtering in real time here. So we can select some type of filtering that we want to add. So first I will make sure to have spectral analysis done also in real time. So when I push the replay button, you see here that I have all my data in also an spectral way. So for example, I can change here the display settings, so I can see it at times versus frequency, and I can start to add a filter. So I have, for example, high pass filter, notch filter, band stop filters, but today I will use the order filter. So let me. So I know that from the gearbox, a very important order is the order 10.24. So I'm just using that to illustrate it a little bit. So when I do now audio replay, I can in real time see how is the effect of this filter. You see here also in the spectral map that you have the effect of the filter. If I turn it off, also the filter is gone here in the map, and I can turn it on also and it will be in the map. Okay, so this is how we do audio replay and filtering. So you can also add more filters at the same time. For example, I can also add some other order filters that in frequency that I know that is important here in this case. So when I do audio replay, so you see in the map they are already there. So when I do the audio replay, I see them all the time, and I can use the bypass filter function. So I can turn off all the filters. And turn on them again during the audio replay. Another last the thing that I want to show is the spectrum average or spectrum live. So you can also see a spectrum of your data, and all the filtering effect will be also in real time. So if I, for example, add the live spectrum here, you see here the displays appears. So when I do audio replay, you see in real time the data, the real data, and the data filter that is the green one. So you can see here there's some effect. So if I bypass the filter now, you see that this is gone. So all the data is the same. And if I activate them again, you see that the data is filtered in real time. So that's another nice thing to see the effect of filtering on your data during audio replay. So in this first demo, we saw how we can use Testlab Neo to visualize the data after the measurement. So with the smart data visualization from the pivot view, you can make sure that you visualize the data exactly in the way you need based on the properties of the data. Also, the automatic displays combined with audio replay and filtering helps you to validate your data on the spot. The last step was using quick spectral data visualization, which also helps to make sure that all the data is correct and we don't need to redo the measurements. So, on-the-spot validation is an important step to be confident that you measured and validate everything on the spot, and you don't need to go back and redo the measurements after the instrumentation is removed. The next step is the NVH data processing. Let's see how it works for the operational NVH campaign. So in this first part, I will show how it's easy to process the data with Simcenter Testlab Process Designer. We have a complete library of processing available, and also it's a very flexible tool that allows you to build your own processing schedules and also save it for later usage. Let's see how it works in the software. So let's start by taking the data that I showed before, so the time data that were measured, and we will add it to input baskets for processing. So when I move to the process designer, I can build process based on the library of processing capabilities that is available. So you see here we have a library with a lot of different processing available. We can also select them from the drop down here. So it's very easy to build your own process. I will start by selecting just some segments of data to be processed, which is also nice that we can do it directly before processing the data. So if I put my display here, I can select from the channels that I have in my input basket. I can select some of the intervals that I want to use for processing. Okay, so let's say that I want to process these two run-ups. So here I have my RPM. So I can, with my keyboard, I can select part of the data. And I can also add a second part that will be used for processing. So you see here I selected two segments. When I check my input here, I can see the segments here, the start and the end of the segment, and also the length. So I can only process data, part of my data, or I can have an option also to process all the data. So it's up to the user to decide. So I will build a small process here, so you can see how it works. So you can select directly from the drop down the process that you want. For example, I will use the split. I will say that only acceleration data needs to pass to this, and all the other will be blocked. And then I want to calculate a spectrum map. If you use that already, you see that the most used methods are here. So you can select them from here or from the list. So I'll use my quick spectrum map. The connection is automatically done. And here I have all the properties of this block. So in this case, I will say that I will track on a channel because I want to use one of my taco channels to track this spectrum map. So let me select the engine RPM, and then I can say if it's a run up, run down, the interval, and etc. Also from the spectrum map, I can say I want to calculate some order sections. So I have here order sections selected, and here I can calculate one or more or different orders at the same time. So I'll say I will calculate these three orders here, and also I can, for example, for the acoustic data that was blocked here, I can say I want to calculate a sound pressure level. So we also have here a sound pressure level block that can be connected here. From my spectrum, I can, for example, also calculate my overall level, which is something that is used a lot in the NVH campaigns, so I can connect it here. And I will finish by doing a run average. So I mentioned that I'm processing two different segments. So for each of the segments, these functions will be calculated. So at the end, if I want to average them and see how it looks like, I can use the run average block. So So I connect here all my data from orders, overall level, directly here to the run average. So I have a process. It's a process here that is used a lot in NVH. I can give a run name. Let's say I will call it a quick processing, and then I can run this process. So you see now the process is running. So we have the progress bar and also the duration. So the two segments are being processed at the same time here. And you see now the data is available. So I can select the active analysis folder, which is where the data is placed before saving to the project. So you see the amount of data that was generated here. I can do a quick check, for example, using a display. I can select some of the data and see if everything is looks fine. So after doing these checks, I can push the accept button. So you see, let me show how it looks like. So there's two processing and also the run average. So if I accept it, it will be automatically sent to my active section. So you see the data is saved in the process. Okay. We can also change to the view data visualization of the processing. So you have the displays back. So if you select now the results from the process, you see that for the two different processing segments, we have the data. So for example, I can show data for one channel altogether in the display. You see here, so these are all the data for this channel, and I can scroll through the results by using my arrow keys and see all the data at the same time. So that's a very nice way to visualize your processing results and see if everything was okay. Let me go back to the processing view because I want to show another very nice thing. So if I take my processing that I create, imagine that you want to use it as a current processing, something that you do several times in different projects. You can select what you just created like this, and then say I want to create a combined method. A combined method it will be a block, a single block that, for example, you can give a name like quick analysis, for example, and then you can save it. You see that it became a block. So it's what we call combined method inside Simcenter Testlab Neo. It's a block that when you double click, you see the processing happen inside, but for the processing it looks like only a box. So you imagine that you can also expand now this processing with other processing and do it all in the same time. And if you want to use it, you can say share to the user level, and then it means that for everybody that use the Testlab installation now, the quick analysis method will be available for usage. So it's a very nice way to save what you progress already, and you don't need to do it again for the next projects. So in this first part, you saw how it's easy and flexible to process data with Simcenter Testlab Neo and the Process Designer. Here we saw how we can build processing schedules from scratch, and also can make sure to reuse it later with the so-called combined methods. To continue with this demo, we use a very advanced processing that we created with Simcenter Testlab Process Designer. It contains three main parts, and it will show how we can do parallel processing in this tool. So the first part of this processing is a transmissibility at a defined constant speed. So we are calculating the transmissibility between the vibrations in the differential and the car seat, and only segments with a certain speed and where the speed is constant will be considered. In the second one, we'll calculate the full prominence ratio map over the complete time trace. We also extract the differentiative number order section that we know already, and we also at the end we use it to plot in a point cloud map display, where it will show this prominence ratio and also the RPM and the power information from the vehicle. In the third one, it's a part where we process multiple run-ups that will be automatically extracted. So we show how we do it in the tool, and only the ones that are considered good, that's criteria that we build based on the acceleration, will be used to calculate order sections, overall level, and at the end run average. So let's see how we do it in the software. Okay, so now we start with an empty process here. For this processing, I have it saved in my installation, so I can use here the open button, which shows all the processing that I have, processing schedule that I have saved in my installation. So I will select the good one. When I push OK, you see the complete process appear. So I will remove it a little bit so we can have space to see it. So you see that we have all the three parallel tracks being processed at the same time, as I mentioned before. I will show you the transmissibility first. So here you see that we have a combined method, and if I double click here, I show exactly how we automatically select the processing segments that we want. So in this case, we have built a process here that will take in ranges of 5 seconds the data. It will check first if the speed is stable. So it's we use the 3 km/h range to make sure that it's stable, and only the segments that have a stable speed will go to the next step, is where we say we want only segments that are between 33 and 36 km/h. So our target's of course 35 km/h. So that's how we do it. So that's how we do automatically segment selection here. So you can create any criteria that you want based on any channel of your data to be processed. So at the end of this processing, only the segments of data that has stable and 35 km/h speed will be processed. And you see here that the FRF is calculated between the two vibration channels. Here for the prominence ratio is the same, so we calculate it over the complete mapping. And also the third one, it's you also have a segment, the automatic segment selection here, where we, based on the acceleration channel, we only select good run-ups, so run-ups where the acceleration was stable. So I will not show it all in details, but it's how we did it. And for the data, for the segments that are selected to pass, we'll calculate overall level, order sections, prominence ratio, and do the run average. So it's a very advanced and complete processing. And what's the key here is that we can process them all in parallel. So let's. So my data is already in my input basket. So I will give a different name here. For example, let's call it full processing. And then I can now run the process. So at the end of the process, we see that the active analysis folder is already populated. So what we have here, you see 4 different run-up segments that is generated from this part of the processing. We have the prominence ratio mapping here that is part of this folder. We have the FRF that is part of the first part, and also the run average. So you can see them all. I'll show in the next step of the demo, but as soon as you accept it, again, the data will be saved in my active section, and then I have all of them available for analysis. So in this first part, we saw how we can process different data in parallel in Process Designer. Also, which is very important in this case with big amount of data, is the smart segment selection. We can do really data mining and make sure that only the segments that of interest are processed. We optimize also as this phase, and also the easy handling of the process results in folders, as I showed in the end. So let's start to see how the results look like. So I'll start by showing the FRF. In the FRF folder, I have an FRF and a Koreans. I can select them to look together. So if I start to zoom in my data, you see that both are zoomed at the same time. So here I have my my Koreans and my FRF, so I can visualize them and see for the different frequencies if I have high transmissibility between the drive shaft and the seat. So that's the first one. The second one I will show are the run-ups. So you see that for each of the good run-ups, a folder was created. So what I have inside is exactly the data that was calculated. So the overall level, the order, the spectrum, and the time data. So if, for example, I select data for a single channel again, so I will select all the data from this channel. You see, I can look at them at the same time. So let me free some space here. So I have all my data at the same time. And what is nice from these pivot tables is that I can use my keyboard to scroll to the other channels. So I can show all the channels here, all the data from different channels just by moving with my pivot table. So which is really powerful, because then I can check for every channel how the data looks like. So these are the data calculated for each of the run-up segments that I have selected. And the other folder that we have is the prominence rate mapping. So you see here that we created a prominence ratio and an order section. So what I can do here is create, for example, one of this point cloud display. When I create a point cloud display and I drop the data, I can I can select how I want to see my order section in function of which parameters of the vehicle. So here I have my RPM, my power that is calculated, that is measured and calculated from this vehicle. I can, for example, change my format to dB level, so I can see it all in dB, and I only check the positive dBs. So I see here for the complete driving that I did with the SimRod, all the information of this order based in function of power and RPM. So I can, of course, use the cursors, for example, the cross cursor, to see exactly which part that was more critical, and then I have the values of power and RPM. So I can scroll through it, and then I have the complete information on which are the hotspots in my data. I can also, for example, say I want to see now the data in function of the engine RPM instead of the drive shaft, and you see that the data was adapted, and I can move again the cursor and show exactly which are the hotspots for that RPM. So this is a very powerful display that shows the complete picture of your measurement. So for long measurement like this one, you can have the complete information on the driving and see which parts of the data you need to focus on. And last but not least, the run average. So again, in the run average, we have different displays. So I can move to my preview back. Okay, and for each of these channels, I have the data that was average from the 4 processing segments. So again, that's the data per segment. Another way to look at this, for example, I can duplicate this display, and I can activate the curve scrolling here. So curve scrolling is a tool that we have that will automatically again scroll through the data. So I can select which method I want to use. And if I use, for example, degrees of freedom, I can just use these arrows, and it will automatically change to the different channels. So you see here now it's showing the Y direction, the Z direction, and the gearbox. So it's another easy way to show data in my software by combining the pivot table and the curve scrolling part. So in the second part, you saw how we can how the results are really organized in folders that are really easy to find inside the software, and also the intelligent displays that we have in place. So it's very important to make sure that all the analysis is done correctly, that these displays are automatically created, and all the data is visualized in the best quality way. Also, with the point cloud display, we saw how it's easy to find hotspots in your data, and for a big amount of data, this is important because you only focus where the data is problematic. Let's say for the NVH, and it's an easy tool to find these hotspots. So for the NVH data process, we saw how we can access in the software a large library of NVH processing that are in place, and also how can you create your own processing based on the existing ones. And what is important also to optimize these NVH campaigns, how to automate your quality checks. So by doing these two steps, you make sure that your time and the quality of your data is optimized, and you don't have the extra delays in the data processing phase of your campaign. So finally, in the last step of this demo, we show how the report and share of results works in Testlab, Simcenter Testlab. So for the reporting and sharing phase, it's really important to have in place tools that helps to define which information needs to be reported. So as we saw before, we have a huge amount of results that are available. So we need to make sure that all the information is there in the reports. For that, we have to make sure that the reports are very interactive, and in this case in Testlab we use what we call query support to make sure that all the data that is in display is the correct data, and we know exactly what is each part of the report. After defining these report templates, we can work with Microsoft Office applications, and so we can immediately send the data in the display to PowerPoint and Word. And there also we can use the so-called print formats that are following the company directives, and everybody in the company can use the same print format, which will make it easier to make it standard throughout the organization. So let's see how it works in the software with this demo case that we are working on. So let's see how we can generate reports with Simcenter Testlab. So in this project, I will go to my print tab where I can open a predefined report template. So that's how I will do it. So I will open my report. And a report template contains several displays with data from the project. So I already drag and drop some data. So you see here, I have some of my data already displayed. And this is how I start to prepare my report. One nice feature here is something that we call the queries. So the displays in Testlab with queries are basically context-driven displays, which data are displayed as queries. If I select to see the queries, you see that the data in this display is shown here as a set of queries, including, for example, the name of the channel, the degree of freedom, where this data is located, and etc. By using these queries, the user can easily modify the queries here, and create new displays with new data in a very easy way, avoiding having to drag and drop again. So one example that we can do, we see that we have X and Y direction here. So if I come here and duplicate this display, I can, for example, give a new name to my Z direction. Okay, and I need to modify the data that's still in the Y direction. So I open the queries of this display again, and you see here in the degree of freedom, I can easily change it to Z instead of Y. I push OK, and then there's this button here where the display will be automatically updated. When I look back to the display, you see here, let me close the queries. You see that the data is already in the Z direction. So it's a very easy way to create new displays for your report. When the report is ready, we go to the print tab, and here we have some options as well. First of all, we need to say what we need, what we want to have in the report. So you can report just a single picture, the complete report, or the preview of the picture. So let's, in this case, keep the report. You can select a different print format template, so you can create templates based on the, for example, with the company logo and some company definitions, or you can use the one that is default in the installation. So that's what I will do today. For the output, you can select PowerPoint or Word, and you can use some other settings. For example, one important one that we'll show today is the active pictures. So pictures from Testlab can also be active pictures inside the Microsoft Office application. I will show in a minute how it works. With that defined, we are ready to print. So just push the print button, so a PowerPoint will be generated. I have already generated this for this video, so I can quickly show. So when I push that button, a PowerPoint like this will be generated. So you'll see one slide per picture, so all the pictures that I defined before. And what is nice about the active pictures is that I can just double click here in this display, and you see that all my Testlab display options are here available. So I can, for example, use cursor. I can zoom it. So it's a picture that that's why we call it active picture, because the user can modify it directly inside the Office applications. And this is thanks to the add-in that we install for free. So any person that will receive a report can install that in the PC without having the need to have a Testlab license, and can play with this, for example, create new pictures and etc. So it's a very nice tool as well that we have for the report. So we see shortly how we can generate reports in Testlab. Of course, there's much more options. You can do much more advanced reports, but this is just an example. And what we saw that is important here is that we can use templates, which speed up a lot this process in NVH campaigns. But also we can have these context-driven displays with showing data as a query, which is also a very nice way to create and modify displays during this phase. Last but not least, we saw that we can use print formats with all the company definitions in PowerPoint or Word, so it also speed up a little bit how the data is reported and shared throughout the company. So the message here is that you can create with your reports with context-driven displays, and also, of course, improve your reporting side with these active pictures, meaning that any person can play with these pictures inside the report directly. So this is some options that we believe that will speed up the reporting phase of your Operational NVH campaign. So this is the end of this demonstration. So we saw that Operational NVH campaigns can be divided in some parts, and all of them need to have optimized tasks, so to the overall we have a very good productivity and a lot of efficiency in any part of the process. We saw that for the test setup and measurement, we need to make sure that we are measuring correctly and documenting the measurement. On-the-spot data validation as well, to make sure that the data quality is assured. The data processing needs to be very optimized and flexible at the same time, so the engineer knows exactly how to proceed. And last but not least, we saw that reporting and sharing of the data can also be very, very time consuming, and we have some tools also to help on that. So with those solutions, I'm sure that we are closing some gaps in the Operational NVH campaign. We put here some of the productivity gains that we believe that we can achieve with this solution. First of all, in the instrumentation and measurement, we believe that by implementing all the features that we mentioned, for example, by combining several different NVH methods into a single campaign, and also making sure the instrumentation and the measurement is done correctly, so there's no test repetition, we can gain up to 30% in time in this phase. For the in-field validation, we saw that it's very important this phase, because it avoids that the data that goes to the processing is wrong. So it's important to have a very well-defined processor here with, for example, the pivot tables that we saw, the smart displays and all the replay and filtering, etc. All these tools will speed up this process, and we believe that we can gain up to 50% of time as well. The next one is the data processing and analysis. We saw that for the big amount of data that we can have in those campaigns, it's important to have data mining in place, which means that segments to be processed needs to be automatically selected by the software, and also all the checks that needs to be done in the data needs to happen in a very automatic way. Also, by being able to process the data in parallel, so we saw that we process in this demo 3 parallel tracks. We also speed up a lot this processing time, and engineers can spend more time in the analysis of the results. So we believe that this will speed up in 40% this phase. And in the reporting sharing phase, by having efficient report creation and with the validated data, we believe that we can also speed up this phase and make sure that the data that is shared in a correct format, in a very automatic way, and also share it to all the person that are interested on that in the company. So we believe that by having these tools in place, the engineers can save up to 50% of time in that part. So you see that by closing those gaps, you can gain a lot of time, and of course, cost comes together with that, so you can also save a lot of money in your Operational NVH campaign by implementing Simcenter testing solutions. So that's the message today. We want to make sure that you know that Simcenter can boost your Operational NVH testing campaign and enable a lot of productivity in any step of your campaign. So thanks for watching, and I hope this material will be very useful for you.